shut things down, that's fine.
Mm-hmm.
So I know with the English classes, a lot of times, like Ashland, their prof actually come out here and they're supposed to drop by, I think, Mr. Martin's classroom a couple times here. If anyone's in his speech class or anything,
They've not been
they're
there.
supposed to, but it's not like they haven't been there yet. Okay, so what did we talk about back in chapter 6?
Oh, we're in a new chapter now.
Yep, we're in chapter 7 now.
Good.
The binomial distributions.
Okay, what kind of variables did we deal with?
Wait, X, N, and P. Right?
Okay, so P was the probability of success, but what type of variable were we measuring?
Oh, you mean like not letters? Sorry.
Overall, what type of variable were we dealing with?
The discrete and continuous.
Discrete, right. Because if we're talking about a basketball player, I can't shoot half a foul shot. I can only shoot a whole number of shots, okay? Or if I'm doing things with cards, only a whole number of a card, integer value. Can't have a part of a card, okay? So now, we're gonna switch things up now. So what were those types of variables called? Yeah, so discrete variables. What are the other type of variables? This goes way, way back to chapter 1.
Continuous.
Continuous now. So now we're going to start looking at, okay, ranges of values. Okay, so that changes the ball game a little bit here. Because now I don't really know for continuous variables, I don't really have a value to plug in for my random variable anymore. Okay, so an example of these kind of things. Okay, what's in a couple weeks?
Christmas.
Okay, so when you're driving places, you probably see UPS vans a lot. Okay, last night on my way into town, and this was at like 6:30, I passed 3 U.S. Post Office vehicles on Smithville Western going down into Overton. So I mean, they're out late at night trying to make all the rounds. So here's what we're looking at, okay? So U.S. Parcel Service, UPS, okay? They're gonna deliver a package to your front door. You usually get emails saying package delivered when you order online. Okay, so they're supposed to drop it off somewhere between 10 and 11, so an hour time window. Okay, now we want to know what's the probability of it being delivered, say, between 10:15 and 10:30, or what's the probability of it being delivered from 10:30 to 11 o'clock. Okay? That's the difference between what we were doing with the binomial probabilities and now what we're doing with what we call the normal distribution of things. Okay? So it's a lot different. Okay? So, what we're going to be talking about first thing, uniform probability. Okay, what does uniform tend to mean?
Like together, like everything is the same.
Okay, so the same, okay, so constant, right? So, what we have here, okay, what we call a probability density function, okay? So if on the calculator sometimes when we were doing like the binomial things, if you see something where it's PDF, okay, that might be talking about probability density. functions. So, two things have to apply still. Probabilities, okay? So, the total area, yeah, what we're talking about is areas under curves. So, for one person, kind of sounds something like back in calculus. We do things with areas under curves, okay? So we're going to use areas to find probabilities of things, okay? With the binomial probabilities, what did the total of all the probabilities have to equal? 1, right? So, this is the same thing, but for the continuous variables. So the area under the graph, or under the curve, has to equal 1, okay? What was the second thing for the discrete variables? What did all the values have to be?
Between 0 and 1.
Between 0 and 1. Couldn't be any negatives, right? So, this is the same thing for continuous variables, okay? So when we're talking about things, the height of it's got to be 0 or positive. Can't have a negative height for anything. So, this is what a density function looks like. Looks like a rectangle. Because uniform means we have uniform height. So it's not like your histograms with the different size bars, different heights on it. So this is what a uniform density graph looks like. So it looks like a rectangle. How do we find areas of rectangles?
Length times width.
Length times width. Okay? So, what did we say the probability has to add up to?
1.
So, whatever your width is, okay, your other factor, your other height, in this case, has to be something that when you multiply it, your answer is 1. So 60, so my height's got to be 1 over 60. If this was 20, what would my height have to be?
1 over 20.
1 over 20. Because the probability has to be equal to 1. Okay? So it's completely kind of brand new. Okay? So, this is 0 to 60 because we were talking about an hour time frame. From 10 to 11, about that UPS truck. Okay, so find the probability of choosing a time that is between 15 and 30 minutes after the hour. What would the density function look like? Do you think?
Since it's between 15 and 30, at least on that graph, it'd be like a little, like a quarter of the way and half the way.
Okay. So that's the area that you were trying to find right there. Since you're told between 15 and 30 minutes after the hour. Okay, so probability-wise, we're looking at P of 15 to 30. So if you're wondering notation-wise, what it would look like. So, what is the height of the density function?
1/60.
Okay, so there's our height. Now, what's the width of what we're trying to find here?
15.
So now, find your probability.
Well, I call it.
So 1/4, 0.25, 25%. Okay, one thing I forgot to mention here, okay? Why we're talking about density functions, okay? In history classes, have you ever talked about how dense the population of a country or an area is?
I remember talking about it.
Okay, what do they mean by how dense?
How many people per like square foot?
Right. So what we're kind of looking at is number of individuals okay, per unit of area. That's why we're talking about areas of rectangles like this. Okay, so now we're going to start looking at the curves and things. So, relative frequency histograms, okay? What kind of shape does this graph take on?
Bell shape.
Okay, bell-shaped. Some of you band people, looks like the end of some of your horns, right? A little bit?
Oh my gosh, I just got that, wow. I feel like an idiot.
Okay, so what we're looking at, when the
Oh
histograms
my
are symmetric
god. Wow.
and bell-shaped, okay, they tend to follow what we call the normal curve. In colleges, you'll talk more about the bell-shaped curve, okay, especially education kind of classes. So, when we start getting and wanting to find probabilities of things, okay, where it's not uniform heights, we can't use the density functions anymore, okay? So that's where we start using the normal probability distributions, okay? So we start bringing back in the mean and the standard deviation of things. Okay? So, this right here, what's u minus and u plus the standard deviation?
One,
That's one standard deviation unit away to either side, right? So, where that hits on the curve, okay? Again, this is something from the calculus classes. These are the inflection points, okay? So if in algebra classes, if I've got a polynomial or a quadratic function How's it open? That graph right here. How's it open? Does it open up or open down? Opens up.
I haven't thought that a lot.
Okay? That's what we call concave up. Okay? If it's like this, that's concave down. Okay? So a lot of you haven't been in calculus. Okay? So those are kind of brand new. So, where you change from being concave up to concave down, that's what they call the inflection point. That's your point where you change from opening up to opening down. Okay? So those points, they always hit, okay, one standard deviation unit to either side of your mean. Okay, now, what point is the mean, median, and mode? Okay, so when it's a normal curve like this, okay, we need to talk about what are the roles of the mean, median, and the mode. Okay, typically, oops, put it down twice, didn't I? That's all one or two funny faces being made. Okay, mode, that's typically your highest point on the graph. Okay, what's the median typically back to middle school?
The middle.
That's the middle, okay? So what do you know about the middle? If I'm smack dab right in the middle, what do I know that's on the left? If I'm smack dab right in the middle. So if I'm in the middle of this room, what do I know is on this side of me? Half the room.
Oh,
What's on this side of me?
the other half.
The other half. So the median is the point where you've got 50% to either side of you. Okay? The mean, that's your balancing point. Okay, so when you have a normal bell-shaped curve like this and it's symmetrical like that, these three values are typically all equal to each other. Okay, mean, median, and mode, when they're the exact same number, okay, you have the entire area underneath shaded in. Now, things are different when you start playing around with the mean or the standard deviation. Okay, so this graph, top one, okay, what changed?
Negative.
Okay, the mean changed. Here it was 0, now here it's 3. So what value changed?
The balancing point.
Okay, the balancing point, okay, what also where the highest point was at, right? Because here the highest point was at 0, but I changed the mean, it got moved over, yeah, the highest point is at 3. Okay, so when you change the mean, it changes where the highest point of the bell-shaped curve is at. Now, what happened when we played around with the standard deviation? How did that change things?
The highest point stays the same, say it's 0, but
Okay, so the highest point, okay, so standard deviation, if I change it, what happens to,
the curve either expands or comes in.
so it gets flatter, or if I make it a smaller number, now it's going to grow. So the standard deviation affects the height and the spread of your values. Okay? So the mean is your highest point where it's located. Okay? So back to pre-calc, it's like your horizontal shift. Shift it left or shift it right. Okay? Now, standard deviation affects how tall the graph is and how spread out it is. Okay, so couple things to note about these normal density curves. Okay, they're symmetric about the mean. Okay, because the three measures are equal to each other. Okay, has only one peak and it occurs where the mean is at. Okay, we already talked about the inflection points occur, standard deviation left or right, area under the curve has to be 1. Okay, area of the right or the left has to be half. Okay, now, here we start talking, kind of sounding like pre-calc again. Okay, decrease without bound. Okay. So as x gets bigger, graph approaches but never reaches. Okay. So as x keeps going, we get closer to the, you might call it the y-axis. Okay. Now, we kind of keep bringing this back a couple times. Okay. The empirical formula. Okay, if we're one standard deviation unit away, 2 deviations, 95% of your values fall within there. Okay. So, now, let's actually make some of these graphs here. So, you've got heights of random 2-year-old boys. Okay? We want to draw a histogram where each class has a width of 1. then based on the shape of it, is it a normally distributed? Variable. So we have to decide if we can use a normal distribution on it or not. That's the first thing we have to decide. Okay? So, make a histogram where your classes have a width of 1, and then find your different heights for the class.
Would we go from 31.5 to 32.5, or would we do 31.5 to 32.4?
Okay? So the first class, okay, starts at, what's your lowest value on here?
31.5.
Okay, so the lowest one, so it'll start on the left at 31.